In this video, we're going to be looking at how we can visualize our trades here in Python using Plotly. So in the visualization I've prepared here, we can see our entry and exit points of any given trade. We can see the time and the price that it took place when we hover over it, as well as the size of that trade in the asset that we're trading, and the percentage profit overall of that trade here. And we've also got a subplot here displaying an indicator, in this case the RSI, with the entry and exit points labeled on there as well. They also share an x-axis, so when we zoom in to a particular point like this, it's very easy to align them to see what's going on with our trades, whether our logic is working properly or not. And we can activate and deactivate any of these traces by just clicking on the right hand side here. So if you need to see the bar that was below that trade, that's easy enough to do as well. And so by the end of this video, you'll have acquired all the skills that you need to make your own backtesting visualization dashboards without having to rely on any other libraries, which may eventually stop being maintained or might just not be suited for your specific purposes. So I'll boot up a new Jupyter notebook here and we'll dig into Plotly. To start off with here, I've imported pandas and pandas TA, which we'll be needing to manipulate our data. You'll also want a source of price data for whatever asset your trades are based in. So in my case, I'm going to generate some dummy ETH trades here. So I've loaded in some Ethereum USDT data. I got this CSV from data.binance.vision. You can go there and grab a free CSV for pretty much all the crypto pairs on Binance. But there are lots of other sources where you can get this data, and I've done a variety of videos on the channel showing you how you can do just that. So we're loading in our open, high, low, close data here. This is going to be important, obviously, for the background of the plot later on. The next step is to create any sort of indicator that we want to plot alongside our price diagram. So I'm just using pandas TA here to generate a simple RSI column based on the closing price. After we've got that, we need to generate some trades. Now, if you've already got some kind of backtesting framework that you regularly use, and you have a list of trades handy, then feel free to use that and follow along with the tutorial using that CSV of trades. But if you don't already have anything like that set up, I built a very basic backtester here that just backtests one basic RSI strategy. We just sell when the RSI is above this threshold, we buy when it's below this threshold, and we always trade $100 at a time. The way it works is we just keep a dictionary here with details about the current trade. If the dictionary is empty over here, and the RSI is below the threshold, then what we do is we enter the trade, and we enter the trade by adding information to this dictionary. So I get the entry price, which is going to be the open of the next candle to avoid look-ahead bias. The entry time of the candle, again, that's going to be the name of the next row in the data frame. We get the size by dividing the amount of money that I'm risking on each trade, divided by the entry price. And then when the RSI goes above the upper threshold and we have some entries in our trade here, then what I do is I close out the trade by setting the exit price here, the exit time, working out the percentage that we're in profit. So if we're at index I and the close value of the RSI is greater than our threshold, add a new trades dictionary to this list here, and then just wipe out everything in current trade and go right from the beginning. So this is a very, very simple backtesting here, just a simple for loop running over the different rows here in our price data frame. Again, if you have your own list of trades, you don't need to bother with any of this. if you have your own backtester that will produce a data frame that looks something like this. We have our entry price, entry time, trade size, exit price, exit time, and the profit percentage. You can of course add as many or as few metrics as you want here. I'll be showing you how to add any of these to the overlay when you hover over a particular entry or exit. And so with that preamble out the way here, let's create our first graph here. So the first thing that we need to do is plot the background open, high, low, close candles, which thankfully is really easy to do in Plotly. They have a custom preset for this. So if you import plotly.graph objects as go, we'll create a new figure here and we'll set that equal to go.figure, and inside here we'll create a candlestick plot. So data equals square brackets go.candlestick, open some round brackets, and then inside here we basically just need our open, high, low, close here. So X is just going to be our open, high, low, close data frame dot index. It's just going to be the time here. So the time on the left, that's the index of my data frame. That's how I made it here. And then we just want to add the open, high, low, close. So I'll copy the name of my data frame here to make this job a little bit easier. It's just open is equal to data frame dot open, high is equal to data frame dot high, low is equal to open, high, low, close df dot low, and same thing for close here. So close equal to open, high, low, close df dot close. So that should generate us a super basic candlestick chart here. If I run that, obviously this is not massively interesting. It does come with this range viewer here by default, so you can zoom in and zoom out. I don't particularly like that, so I normally get rid of it, which you can do by doing fig.update layouts x-axis range slider visible equals false. Let's go ahead and rerun this cell. So there we go, got rid of that annoying range slider there. Another thing I'm going to do is I'm going to change the color and the opacity of these candles here, because they can get in the way if they're these very vibrant colors. We don't necessarily want them getting in the way of our order visualization, as we're more interested in our entries and exits here. The way that we can sort that is by setting the increasing and decreasing line color here. So increasing line color. So this is going to be our green bars essentially. We can change this to whatever we want. And a handy little trick with Plotly here is that you can set your colors to RGBA values, just like you would in CSS. So you have a red value, a green value, and a blue value here, as well as an alpha parameter here, which specifies the transparency. If you're not sure what values to use in here, you can go to rgbacolorpicker.com, which is conveniently named. Pick a color that looks nice to you, that's not too distracting, set your transparency level, take these values and just put them into here. I've used these values before, I like how they look. And then we just do the same thing, but for the decreasing lines here. So these are going to be what would be our red candles, but we're now going to change them to different colors. I'm going to change it to 210, 210, and 210 here. So I believe our up candles should be like gray, our down candles are closer to black, or the other way around. Either way, they're less distracting now, and they won't hinder our ability to understand the chart here. Now let's add our entry signals. So before we do this update here, we'll do fig.add trace. And the way we're going to implement this is as a scatter graph here, albeit a rather strange one, where our x values are going to be the time at which the entry took place, and the y value is going to be the price at which it occurred. So it will be centered on the price at which it was bought at the time at which it was bought. Now we thankfully have our trades here as a nice data frame just called trades. So what I can do is I can just say I want the x to be the entry time and the y to be the entry price here. So x is going to be equal to entry time, or rather trades.entry time. And the y-axis is going to be trades.entry price. Let's see what happens if I plot this. I'm interested to see what happens. So yes, it's plotting the entries in the right place, but it's joining them together with a line, which you probably don't want overall. And so to get rid of that and customize the style here, we can set the mode here. So mode is equal to markers. And what that will do is it will instead just plot singular points rather than joining them all together, which is exactly what we want. And if you want to customize what this marker looks like, there's a bunch of different options here on the documentation. If you just Google styling markers Plotly, you get this page. And if you scroll right the way down, there's this nice little table here that gives you all of the different options of the shapes that you can have. I've chosen this one here, which is the diamond dot, but feel free to experiment and see which one you like best. So I'm just getting the name from this hover tag here. So name is square dash dot or diamond dash dot. And in order to change my markers to look like that, all I have to do is do marker underscore symbol is equal to diamond dash dot. Run the cell. And there we go. We've got a little diamond as our entry price here. We can do some other things to make it look a little bit more interesting and to separate it from the exit markers when we add them later on. We can change the size, so marker size, I'll set that to 13, make sure it stands out. We can also set the line width here, so that's going to be the outside line around the marker. So this is what that looks like now. It stands out a little bit better against the background. And we can also change the color here. So this is red, which to me at least makes me think it's an exit. So we want to change the color to something like green. And we can pull our same trick with the RGBA values. So we do marker line color is equal to RGBA, and then select your RGBA values. I'm just going to select pure green here, so 255 for green, 0 for red and blue, and an alpha value of about 0.7, just so it's not too crazy with the color. That's not what I intended. The marker line color is the line around the marker, as we can see. I want that to be black, so I'm going to set that to 0, 0, 0. And there's a separate variable called marker color, and this is the one that contains the actual marker color, which I'm going to set to green here by setting the green value to the maximum. Okay, so this is looking significantly better here. The only thing we have to do is add our custom hover data here. What is showing right now is the X and Y values. So the X value is the date, the Y value is the entry price, which is great, but doesn't give us an awful lot of information. So what we can do is we can change the hover template here. So hover template, and this is going to be a regular string, but we're going to include some special syntax that lets Plotly know when to replace a value by a variable. It's a bit like F strings if you've used those before. We'll start simple and we'll just include the entry price here. So entry price, colon, and then percent curly brackets, and inside here you want your variable. So in my case, the entry price is just Y. So I can just put a Y in here, and it'll know to replace the entry price by whatever the Y value is. Let's see what that looks like actually. So we can see now it's got entry price and the price of the entry. What I can also do if I want to is format this to a specific number of decimal places. So if you do .2f, that will format it to 2 decimal places. So that's all well and good, but how do we get any other data that isn't just the X and Y values? The way we do that is through the custom data parameter here. So custom data, and I'm going to set that equal to trades here. So just our data frame full of trades information. And what we can do is we can index into this in order to get the values that we want. So if I wanted to display the trade size, I would index into custom data at the second index here. So counting from 0, 0, 1, 2. Let's implement that here and you can see what I'm talking about. Another cool thing about these strings is that they implement HTML here. So this BR here stands for break and will give us a new line. I'll then continue this string on another line here. So I'll do plus backslash and that will let us continue this line as if nothing happened. And I'll do size is equal to % custom data 2. And then I'll trim that to 5 decimal places like I did before with the .5f. So hopefully that's reasonably straightforward. You could have this as one long string here if that syntax is confusing you. I just think it makes it look a little bit easier to read if you've got the different attributes on the different lines. So I'm going to format it like that. Let's see if that worked and what it looks like. So I can click on any of these now. And we've got the size formatted to 5 decimal places, which is what we wanted. So let's go and quickly add in the entry time and the profit percentage in here and show you just how easy it is to add all this extra information. All you have to do is paste one line that we've already got, plus backspace, tab in the appropriate amount. I'll use entry time here. Now entry time is the first index in here, so 0, 1. Let's use that. We don't need to do any of this number formatting because it's not a number. And we'll make sure to include a line break here on the end. So we've got the time, the price, the size. And finally, I would like to add the profit percentage here. So I'll copy this one and again, make sure to add a line break. Plus a backslash, and then on the next line here, let's add profits percentage. And what's that going to be? Well, that is 0, 1, 2, 3, 4, 5. So the 5th index into our trades data frame here. So down here, the number 5, and I'll format it to 3 decimal places. We'll see what that looks like. And that's looking good to me. We've got our entries properly labeled here. What you can also do as we start getting lots of different traces here on the right hand side is we can give them a name. So if we go to the end here, we can add a new parameter, call it name, and that's going to be the entries. And then we can do the same thing for the open, high, low, close here. So name is equal to open, high, low, close. There we go. We've got our names on the right hand side here in the legend. Now that we've got that, it's very, very simple to add the exit. So you can just copy and paste the whole thing. Change the colors, basically. That's all we need to do. So instead of all green, it's all red. 255. This is going to be the exit time, but otherwise is relatively unchanged. We just need to grab the index here. So 0, 1, 2, 3, 4. Similar sort of deal with the price here. So 0, 1, 2, 3. 3 is going to be the index. Although actually we're using Y here, remember? So Y is just the exit price here. Therefore we don't actually need to index into custom data. And I'll just change the label here to exit price and exits. And if I haven't missed anything crucially important here, that should be good. So we've got our entries and our exits properly labeled here on this graph. And this is already way easier to read than just a list of trades like this. And we've built it ourselves without relying on some backtesting framework, which we don't necessarily have control over, implemented in just a raw plotting library like Plotly, which is unlikely to go anywhere anytime soon. Now that we've got this, let's go ahead and add our indicator to it. So we'll add the RSI below here, and we'll add the entry and exit signals onto our indicator so that we can check that everything's working properly. In order to do that, we'll need to create 2 plots rather than just one. So from plotly.subplots, we'll import make subplots here. And then rather than creating figure here, we'll make a figure at the top using make subplots. So make subplots. We set the number of rows that we want. So rows is equal to 2, columns is equal to 1. So cols equals 1. That should be good for now. And then instead of doing fig equals go.figure here, what we're instead going to do is fig.add trace. So we're getting rid of most of this first line here. Get rid of that bracket that we don't need anymore. And that should basically work. The only major change we'll have to make here is we'll want to specify which of the plots that this one goes on. So this is our open, high, low, close graph, which I want to be in row 1 and column 1. So row is equal to 1 and col is equal to 1. So you do that in the outside set of brackets here, this final set of brackets. Inside add trace, you can set your row and column that you want to use. Now I'll go ahead and do that for all of these here. So I'll just neaten up the syntax here. Set the row and the column, and I'll do the same for the exits. Let's see what that looks like. Figure has no object add trade. Yes, because it's add trace. And there we go. We've got 2 plots here. Now, you can't see anything on the second one because we haven't plotted anything on it, but rest assured it does exist. Let's add our RSI on there so we can see what that looks like. It's the same thing that we've been doing this whole video. We'll just do fig.add underscore trace. And this time we want to add a conventional scatter plot here with the x value equal to open, high, low, close df.index, the y value equal to open, high, low, close df.rsi, and the name we just want to set to RSI here. Then we can define which row and column it belongs to. So I'll set row is equal to 2, col equal to 1. Indent it a little bit here so it's more obvious what's going on. And if we run that, we have our RSI plotted here below. One thing which you'll immediately notice, however, is that they're not linked in any way. So I can zoom in as much as I want on this one, and it doesn't change what's happening below. We don't really want that behavior, and the way to fix it is very simple. You just have to do shared x-axis up here. So shared x-axis equals true. And that will fix that for us. So now whenever I zoom in on a specific point or set of candles, it will automatically zoom in on the x-axis here, and they'll be perfectly aligned for us. I also want to make the open, high, low, close graph a little bit larger, as we don't really need all this space for the indicator, but the candles are looking quite cramped. So the way to fix that is we can just set the row heights here, so row heights. And then you can just give it straight up numbers. So I want the first row to take up, let's say, 0.75 of the space, so 75%. And the second row, I want to take the other 25. Let's see what that looks like. It's complaining. Unexpected keyword row height, because it is row height with an S. There we go. So now our indicator is significantly smaller here. We can also change the vertical spacing between them here, so that might seem a bit large to us. We can easily change that over here. Just a new parameter, vertical spacing. I'll just set it equal to 0.1. We'll see what that looks like. Let's see what it's complaining about here. Vertical space. It should be vertical spacing. There we go. So now there's less of a gap between these two plots, which gives us more space to actually view the stuff we're looking at. And the final thing that we really want to add here is our signals onto this graph here. So we'd like to plot on this RSI curve when our entry and exit signals are triggered, so it's easier to read what's happening and we can check that our execution logic is actually working, as it's often very difficult to tell what's happening if you just have this faceless list of trades here. It can be difficult to check that your backtesting engine is doing what you actually expect it to do. Now, for the most part, what we can do here is we can just straight up copy the entries and exits before and make a few little adjustments to them. The first would be to get rid of the hover template. At least I'm not planning on using it, so I'll get rid of that. We'll change the name. So I'll call it the indicator entry, just to make it different from the other entry. And we can also change the marker type. So I'll change it to circle dot instead of diamond dot. And instead of plotting the entry price, what we want to do is we want to plot the RSI at the time that we entered. So open high, low close, or wherever you're getting your indicator data from, .RSI. And we want to index into there with .lock trades .entry time. So this will get the RSI values for every single time we entered a trade. That's basically what this gets. We can change some things like the marker size. Maybe it doesn't need to be quite as big because the graph's a bit smaller. Remember to, of course, draw this on the second graph, otherwise it will look a little bit silly. And let's see what that looks like. So there we go, we've got our entries labeled here. Now this is by default going to be labeled at the point at which we made the entry, which is slightly different from when the signal was generated. Because in the backtesting engine I created, we're buying the asset on the open after the close signal has been generated. We might actually want to plot this when the signal was generated rather than when it was activated. I'll show you how to do that after we add the exits here. Again, that's just going to be a very quick copy and paste job here. So copy and paste what we've got so far. It's going to be indicator exits. This is going to be exit time. And this is also going to be exit time. We'll change the color to be red rather than green here. So 25500. Let's see how that is looking for us. And so this is the graph that I presented to you at the beginning of this video. These entry and exits line up here. So you can see what was the value of the RSI at the time that the signal was executed upon. Now, to avoid confusion and to make sure that our backtest is behaving properly, I'm going to shift these backwards one to the point where the signal was actually activated rather than when it was executed. There are a few different ways of doing this. One would be to record when the signal was created inside your trades table here. So you'd have an extra column here that tells you when the exit signal was generated and when the entry signal was generated. I'm not going to do that because that involves adjusting my backtesting engine here. So I'm just going to take the easy route and I'm just going to take an hour away from the times. So from date time, I want to import time delta. And all I'm going to do is, instead of plotting the entry time here, I'm going to plot the entry time minus time delta hours equals 1. So obviously, depending on what time frame you're using, this will look slightly different. In fact, we can make a variable here so it's slightly less disgusting. We could have bar frequency is equal to time delta hours equals 1. And then instead of hard coding that, we can just minus bar frequency here. And copy and paste that in a few times to our entry and exit signals. Now, if we zoom in here, get a closer look, we can see that these are now being generated at the appropriate times, which can be slightly less confusing, because otherwise you might look at this example here, and if the signal is on this bar, you might think, why is it being generated? The RSI is 65. But if we plot it properly, where the signal was actually generated rather than where it was executed, we can see that the RSI is above 70 here, and therefore our signal generation is working as intended, and we're all good. So that's it for this video. I hope this helps you build out different graphs in Plotly to find any small errors in your order execution, and to make sure that your backtests are simulating your strategy to a T. And with the skills that you've learned, you'll be able to create your own custom dashboards rather than relying on pre-built ones in whatever backtesting framework you're using. So I hope you enjoyed the video, and I'll see you in the next one.